We are going to start now lecture 5 of chapter 9 class 11th mathematics, sequence and series. So in this lecture we will talk about certain problems related to the arithmetic progressions. So the first thing we are going to discuss over here, it is when the ratio of the sums is given and we have to find the ratio of the common terms. So we are saying if the ratio of the sum of m and n terms of an AP is given by this formula, where a and b are constants, and if we have to find the ratio of the terms, the ratio of the mth term to nth term. So we are saying it is given that Sm is equal to am square plus bm divided by Sn is equal to an square plus bn. Now what we obtain from this results is that for some constant k, Sm is equal to am square plus bm into k, and Sn is equal to an square plus bn into k. Now if we want to calculate So based upon this we have this next question. It is the ratio of the sum of the mth term to nth term, it is given to be equal to m square by n square. We have to prove that the ratio of the mth term and nth term is this. So we are writing that the ratio of Tm is to Tn, that is equal to, we are saying the formula we have, it is a into 2m minus 1 plus b. If we have over here am square plus bm, so compare this value, we have the value of a is equal to 1, we have the value of b is equal to 0. So what we obtain is, it is 2m minus 1 over 2n minus 1. So this is the answer we have obtained in this case. Next is if the ratio of the sum of mth term of two APs is given. We are saying there are two different AP. The ratio of the sum of the first to the second, that is equal to, suppose we write it is S dash n, that is equal to a n plus b divided by c n plus d. So we are saying again Sn is equal to a n plus b into k, Sn dash is equal to Cn plus d into k. We have these two values. Now Tn will be given by a into 2n minus 1 plus b into k, and in this case Tn dash will be given by c into 2n minus 1 plus d into k. Now if we divide both these values, we will obtain the answer that Tn by Tn dash or Tn by Tn dash, that is equal to a into 2n minus 1 plus b divided by c into 2n minus 1 plus d. And if we have to calculate the ratio of their common difference, then we know that the common difference is d, that is Tn minus 1, that is equal to 2 times a, and common difference d dash will be T dash n minus Tn minus 1 dash, that is equal to 2c. So the ratio d over d dash will be a over c. So this is the ratio that we will have. So these are the answers we obtain in this case. Now we are saying if a is equal to c is equal to 0, then Sn over S dash n, that is equal to b by d. So this implies us that Tn over Tn dash, that is equal to b by d, and this implies us d by d dash, that is equal to 0 by 0, and it is not defined. Next is, if Tn by Tn dash, that is equal to an plus b divided by cn plus d, where a, b, c, d are constant and a and c, they are not equal to 0, then the converse part we have is that the ratio of Sn to Sn dash, this value we will have, the formula we have, it is a into n plus 1 by 2 plus b divided by c into n plus 1 by 2 plus d. So this is the formula we have if the ratio of the terms is given and we have to calculate the ratio of the sums. So based upon this, the first question we have is, the sum of n terms of two arithmetic progressions are in the ratio. So it is Sn over Sn dash, it is given to be 7n plus 1 over 4n plus 17. We have to find the ratio of their nth terms and also the common difference. So we know the formula, it is Tn over Tn dash, that will be equal to 7 into 2n minus 1 plus 1 divided by 4 into 2n minus 1 plus 17. So answer we obtain 14n minus 6 divided by 8n plus 13, and d by d dash we have, it is equal to a by c, that is equal to 7 by 4. So these are the two answers that we will have in this case. Next is, the sum of the n terms of two APs are in the ratio. This, it is Sn over Sn dash, it is given to be 3n minus 13 by 5n plus 21. Find the ratios of their 24th terms. So we have to calculate the value of T24 by T dash 24. So the answer in this case, the formula we have, it is 3 into 2 into 24 minus 1 minus 13 divided by 5 into 2 into 24 minus 1 plus 21, and the answer we obtain, it is 1 by 2. So we are saying that the ratio of the 24th terms of these two sequences, it is 1:2. Next is, how many terms of the series this must be taken to make 300, and we have to explain the double answer. So we are saying the formula for sum of the series Sn is equal to n by 2. Suppose we are saying n terms are there. First term is 20 plus n minus 1. The value of d that we have in this case, it is 2 by 3. This is the value of d that we have, and we are saying that the sum should be equal to 300. So on solving this, we will obtain that when you solve this equation, you will get 600 is equal to n into 40 plus n minus 1 into 2 by 3. If you solve this equation, you will obtain n square minus 61 n plus 900 is equal to 0. We get n minus 25 into n minus 36 is equal to 0. And this implies us that n is equal to 25 or 36. These are the two values of n that we have. Now, why these two values of n are there? Because we are saying, if we are writing the terms over here, it is 19 whole 1 by 3, then 18 whole 2 by 3, and continuing in this way, there will be a term 0, and after this there will be negative terms. So we are saying that I am again writing these values, it is 20, 19 by 1 by 3, then 18, 2 by 3, so on up to, there will be a term that is T25, then we are continuing in this way, and there is a term that is T36, and so on. So what we have is that the sum of the terms between these two, or we are saying the sum of the terms, all these terms, that is equal to 0. Why? Because there is a number 0 over here, there are negative terms over here, positive terms over here, and sum of all these terms is equal to 0. So we are saying that is why we have the double answer over here. Now next we have is find the arithmetic progression consisting of 10 terms if the sum of the terms occupying the even place is equal to 15 and the sum of those occupying the odd places is equal to 12 whole 1 by 2. So we are talking about T1, T2, so on up to T10. There are total 10 terms. And those occupying even places, the sum is 15. So it is T2 plus T4 plus T6 plus T8 plus T10, that is equal to 15. And we have T3, T1 plus T3 plus T5 plus T7 plus T9, that is equal to 12 whole 1 by 2. Now if we look at this sum, this is also an AP, and the sum of this AP it is given by 5 by 2 into T2 plus T10, and the answer we have equal to 15. And this second AP we are talking about, its sum is 5 by 2 into T1 plus T9, that is equal to 25 by 2. Now if we solve both these, we have this term T2 is A plus D plus A plus 9D, and the answer we will have, that is equal to 6. And in this second case we have A plus 8D is equal to 5. So we have two equations now. First is 2A plus 10D is equal to 6, and second is 2A plus 8D is equal to 5. Now if we solve both these equations, we will obtain D is equal to 1 by 2 and A is equal to 1 by 2. We have these two equations, and if we solve these two equations, we will obtain the value of A and D. So the AP we obtain, A is 1 by 2, then D is 1 by 2, so next term is 1, then next is 1 whole 1 by 2, next is 2, next is 2 whole 1 by 2, and so on. So this is the required AP which satisfies the given condition. Now next we have is, if n the set of natural numbers is partitioned into groups and it is S1 is equal to the set 1, S2 is equal to, it is having two elements 2 and 3, S3 is equal to, it has 3 elements 4, 5 and 6, and so on. We have to calculate the sum of the numbers in S50. We have to calculate the sum of the numbers in S50. Now the number of terms in this set, the number of terms, whatever this set is, the number of terms, that will be equal to 50. For 1 it is 1 term, for 2 it is 2 terms, for 3 it is 3 terms. And the terms that we will have over here, if we talk about the last term, look at this first set S1, we are saying the last term we have over here, it is 1. In the second group, the last term we have, it is 3, that is equal to 1 plus 2. Over here the last term, it is 6, that is equal to 1 plus 2 plus 3. Now if we are talking about the last term of the 49th group, S49 we are saying, the last term will be 1 plus 2 plus 3 plus so on up to 49. And if we are talking about the first term of S50, now we are talking about the first term, this is the last term over here. So the first term, term 1 over here, that will be 1 plus 2 plus so on up to 49. So this sum is equal to 1 plus 49 by 2 into 1 plus 49. So the answer we obtain 1226. The answer we obtain, it is 1226. So now we have to calculate the sum of the n terms. So S50 is equal to 50 by 2 into 2 into 1226 plus 50 minus 1 into 1. So answer we obtain, it is 25 into 2501, that is equal to 62525. So this is the sum of the 50 terms over Now next we have is, suppose a sequence is given and it has the terms t1, t2, t3 and so on, and we want to calculate the sum of the first 24 terms. We want to calculate t1 plus t2 so on up to t3, 23 plus t24. We want to calculate this value, and it is being given that t1 plus t5 plus t10 plus t15 plus t20 plus t24, that is equal to 2 to 5. This value is given to us. Now we know that the sum of the terms equidistant from the beginning and the end is always same and equal to the sum of the first and the last term. So what we obtain from this is that t1 plus t24, that is equal to t5 plus t20, that is equal to t10 plus t15. We are talking about these values over here. Now if we substitute these values in this formula, we will obtain, when we substitute these values over here, we will obtain that 3 times t1 plus t24, that is equal to 2 to 5. So this implies us that t1 plus t24 is equal to 75. Now we want to calculate the sum of the 24 terms. So the value of the sum of the 24 terms, S24, that is equal to 24 by 2 into t1 plus t24, and the answer we obtain, it is 12 into 75. This value we have, and this is equal to 900. So this is the sum of these terms. Now next we have is, if 1 plus 3 plus 5 so on up to p plus 1 plus 3 plus 5 so on up to q, that is equal to 1 plus 3 plus 5 so on up to r, where each sets or each numbers in these brackets, they contain the sum of consecutive odd integers. Then we have to find the smallest possible values of p plus q plus r. So we are saying that 1 plus 3 plus 5 so on up to plus 2n minus 1, that is equal to n square. So the sum of these terms for this first bracket, the value of the sum that we have, it is p plus 1 by 2 square. For the second bracket, the value we have, it is q plus 1 by 2 square, that is equal to r plus 1 by 2 square. On solving this, we will obtain that p plus 1 square plus q plus 1 square is equal to r plus 1 square. So these three numbers, if we look at, we are talking about p plus 1, q plus 1 and r plus 1. These three numbers, they form the Pythagorean triplet. Now we are saying the condition given to us is that p is greater than 6, and for the sum number 7, we are saying the first Pythagorean triplet that we can have, it is 6, 8 and 10. So we are saying if we take the value of p plus 1 is equal to 8, q plus 1 is equal to 6 and r plus 1 is equal to 10, then we will have p plus q plus r, that is equal to 21, and this is the value we have to calculate over here. This is the smallest possible value of p plus q plus r. Next is the digits of a positive integer having 3 digits are in AP and their sum is 15. So if we are talking about the digits of a positive integer, so suppose we are saying at units place, the digit we have, it is a minus d. In the tens place, it is a, and in the hundreds place, it is a plus d. So these are the three numbers which are in AP, and these are the digits of a positive integers of 3-digit number, and their sum is given to be 3a is equal to 15. So we have value of a is equal to 5. Next, it is given that the number obtained by reversing the digits is, so if we are substituting this value, we are saying the digits we have is 5 minus d, 5 and 5 plus d. Now we are saying the number obtained by reversing the digits. So the original number we have, it is a minus d, that is 5 minus d plus 10 into 5 plus 100 into 5 plus d, and the new number we are talking about, that is obtained by reversing the digits, it is 5 plus d plus 10 into 5 plus 100 into 5 minus d, and we are saying the number obtained by reversing the digits is 594 less than the original number. So it is being given that first we are calculating the values over here. So on solving this, we will obtain this is equal to 555 plus 99d, and this number we will obtain, it is 555 minus 99d, and now from this condition we are having 555 plus 99d minus 555 minus 99d, that is equal to 594. So this implies us that 198d is equal to 594, and this implies us that the value of d that we have, it is equal to 3. So the number that is formed over here, so the number that is the original number, we are saying it is 555 plus 99 into 3, that is equal to 852. So this is the required number. Now next is, if 3 positive real numbers are in AP, so suppose we are saying the ABC, they are in AP, the value of B we are considering it is A, the value of A we are considering it is A minus D, and the value of C we are considering it is A plus D, or we can write capital D over here in place of small d. Now it is being given that A into B into C is equal to 4. So what we are obtaining from this is, we are saying if we substitute this value of B is equal to A in all these equations, this will become B minus D, this will become B plus D. Now it is given that A, B, C is equal to 4. So we get B minus D into B plus D is equal to 4. The capital D over here. So on multiplying these terms, we will obtain that B into B square minus D square is equal to 4. Now look at this value B square, it is greater than B square minus D square. So we are writing this term, we are writing 4 is equal to B into B square minus D square, and this term we are saying it is less than B into B square, that is equal to B cube. So what we obtain is that 4 is less than B cube. We have obtained that 4 is less than B cube. So we are saying that B is greater than 4 raised to the power 1 by 3, or we can write 4 raised to the power 1 by 3 means 2 raised to the power 2 by 3. So we obtain the final answer in this form, that we are saying the minimum value of B is 2 raised to the power 2 by 3. Next is, if A, B, C, D are distinct integers and they form an increasing AP. So we are saying A, B, C, D, they are distinct integers, they are in AP, and these values, these are in increasing order, such that D is equal to A square plus B square plus C square. Then we have to find the value of A plus B plus C plus D. So suppose we are writing, it is being given that these are the increasing AP. So we are writing, suppose B is equal to A plus D. D is the common difference over here, and C is equal to A plus 2D, and D is equal to A plus 3D, where we are saying D is any positive, D is belonging to n, it is any positive integer, because A, B, C, D, these are integers, and further they are increasing integers over here. So the value of D we have, it is positive. Now if we substitute these values in the given condition, in this given condition, we will obtain that A plus 3D, that is equal to A square plus A plus D square plus A plus 2D square. Now if we solve this equation, we will obtain 5D square plus 3 into 2A minus 1D plus 3A square minus A is equal to 0. Now on solving this, we will obtain the value of D is equal to minus 3 into 2A minus 1 plus minus square root of 9 into 2A minus 1 square minus 20 into 3A square minus A and whole divided by 10. So on solving this, we will obtain, I am talking about the value over here, this value we are saying, when you simplify this value, you will obtain it is minus 24A square minus 16A plus 9, and this value should be greater than 0. We are saying minus 24A square minus 16A and plus 9 is greater than equal to 0, and if you solve this equation, when you solve this equation, you will get the values of A is equal to minus 1 and 0. So these are the two possible values that we can have. Now if we substitute A is equal to 0 in the equation, we are talking about this discriminant equation, the discriminant will become equal to 0 and 3 by 5. Now clearly both these values of D are not possible, because if D is 0, then this AP will become a constant AP, but it is given that it is increasing, so the value of A is equal to 0 is not possible. Further, if we substitute D is equal to 3 by 5, it will give us the non-integer answers. Now if we substitute A is equal to minus 1, when we substitute A is equal to minus 1, we will have D is equal to 1 or 4 by 5. This 4 by 5 is not possible. So we are having the value of A is equal to minus 1 and D is equal to 1. So what we obtain from this is the value of B we will have, that is equal to 0, the value of C we will have, that is equal to 1, and the value of D we will have, that is equal to 2. So these are the values that we will have now. These are the values, that is A is equal to minus 1, B 0, C 1 and D is 2. And the sum of all these values, A plus B plus C plus D, we are saying the sum of all these values, we are saying it is equal to 2. And this is the required value in this case, that is we have to calculate the value of A plus B plus C plus D. This is the required value.